Level 1. Diffuse Aurora. A soft glow rises before anything dramatic, like breath on a winter mirror stretched across the night. This is the diffuse aurora, hazy, milky, everywhere and nowhere at once. The sky doesn't ripple yet. It whispers. Electrons, guided by Earth's magnetic field, drizzle into the upper atmosphere and collide with oxygen and nitrogen. Around 100 kilometers up, excited oxygen atoms let go of energy as green light. Higher still, thin air bleeds red. You tilt your head back and the world feels dimmed, as if someone turned the night up one notch. Stars fade behind the veil. Your eyes adjust and the glow broadens, blending into darkness without edges. There's no curtain here, no sharp river of light, only the suggestion that space is touching you gently. From a city, you might never notice it, but under a truly dark polar sky, your camera sees it before you do a faint wash. The sensor grabs greedily while your eyes hesitate. Long exposures reveal structure the brain smooths away. What feels like mood to you is a torrent of particles, billions per second, sliding down along magnetic field lines you cannot see. Scientifically, diffuse aurora is the background chorus. It forms when waves in near-Earth space scatter electrons from the plasma sheet, smearing precipitation over wide regions. To instruments, it is power. To you, it is anticipation. On quiet nights, it can be too faint to notice. On active nights, it becomes the stage light that hints at what's coming. You feel nothing on your skin, only cold air and the sting of waiting. But if you could stand at the edge of the magnetosphere listening, you'd hear a hiss of charged particles and the rumble of a distant storm. Diffuse aurora matters because it sets the baseline, the canvas upon which everything else is drawn. And just when you begin to doubt your eyes, something slender sharpens out of the haze. Level 2. Quiet arc. A single arc snaps into focus. East to west, a luminous river hung along an invisible rail. It holds still. It dares you to breathe. This is a quiet arc, a steady band of green tracing the boundary where magnetospheric currents feed the upper atmosphere. At roughly 110 kilometers, oxygen sings green at 557.7 nanometers. Knife bright, unreal. You step into the snow, and the crunch feels louder, as if the sky is swallowing sound. The arc has edges now. It has a backbone. It stretches from horizon to horizon, perfectly aligned to Earth's magnetic field. The planet's shield becomes geometry in the air. Time-lapse it, and you see it creep and thicken, as if something is winding up behind the scenes. Magnetometers twitch. Satellites sense subtle plasma flows around Earth. To you, it's a single line. To space, a pressure gauge sliding toward the red. Quiet arcs are signposts. They tell researchers where energy is flowing along field lines. They tell you, wait, you might notice a soft red cap above the green. Oxygen at higher altitudes, where collisions are rare. You might catch a hint of blue from molecular nitrogen deeper down, but mostly you see a promise taut and humming. If you're flying under this arc in a jet, your window fills with a sheet of brightness so close you could reach it. You can't. It's 100 kilometers up, but the world below, your phone, your compass, begins to feel small. Quiet arcs are the bones of the aurora, and bones, given a jolt, begin to move. Even stranger is what comes next, when the arc fractures into 1,000 shimmering ribs. Level 3. Rayed curtains. The river rips into curtains. Vertical striations descend like bright strings from a glowing rail, each ray tracing a magnetic field line deep into the atmosphere. The sheet ripples in a wind you cannot feel. Waves race along the arc at hundreds of meters per second, and your brain insists the sky has become a living ocean. Stand beneath it, and your depth perception rearranges. The rays flicker, start-stop, as electrons arrive in bursts. The lower edges curl into drapes that twirl and fold. Each ray is a column where electrons collide with air kilometers thick, 1,000 long. The physics is sculpted by field-aligned currents and plasma instabilities that let particles tumble inward like snow sloughing from a ridge. Hover there, and each ray becomes a hollow tube, bright on its edges, where collisions peak. You would float in a forest of light, every trunk a current linking space to Earth's skin. You'd feel nothing, but you'd be inside a circuit closing through the ground beneath someone's boots. This is the aurora most people imagine the classic curtain, moving with a dancer's grace and a storm's impatience. Colors intensify. Emerald at the base, a ghostly red above, purples lacing the edges where nitrogen glows. Cameras feast. Your eyes chase patterns until you forget to blink. For you, wonder floods the chest and steals your words. For technology, those same currents can induce electric fields and power lines and whisper errors into radio links. The planet is humming. You are inside the instrument, but rhythm soon fractures into beats patches that blink like the sky has a pulse. Level 4. Pulsating aurora. The curtains fade into islands' pale ovals, and amoebas switching on and off, beat after beat. One patch blinks every few seconds. Another flutters many times a minute. This is pulsating aurora, the heartbeat of space weather mapped onto the night. You lie back and watch neighborhoods of sky flicker. Far above, electromagnetic chorus waves scatter electrons out of their magnetic traps. Those electrons rain down in packets, turning the patches on, then letting them go dark. On radio, you could hear the chorus as rising whoops, the magnetosphere singing to itself while the atmosphere keeps time. Speed the footage and the sky breathes. Patches expand and contract like lungs. Sometimes they drift and merge like clouds. Sometimes they strobe so fast your vision smears. Then they stop, as if something in space threw a switch. Nothing bites your skin, yet the on-off electron rain disrupts high-frequency radio and over-the-horizon radar. Satellite operators track the same waves because they can rattle spacecraft. The aurora is not a picture, it is a process. A conversation between Earth and the solar wind. Every conversation has silence, a darkness that isn't absence, but anticipation. Level 5. Black aurora holes open in the light. Not gaps between curtains, holes inside the emission itself, moving as deliberate shadows. That is black aurora. Dark lanes carved through glowing plasma by fast field-aligned flows. Where electrons are drawn away or blocked, the sky goes mute, cutting ink strokes through the green. You feel your stomach drop the way it does on a mountain road when the guardrail disappears. Your eyes chase the darkness because it's darker than the night around it. Negative space moved by invisible hands. The black lanes wiggle and dart, following convection channels where the ionosphere briefly says, "Not here." If you track those shadows in time lapse, they slither and swirl like living calligraphy, tracing unseen rivers through a luminous sea. Some widen, others pinch and vanish, replaced by new ones seconds later. In that interplay of brightness and absence, the magnetosphere is sketching its electric anatomy. Scientists read these voids as fingerprints of electric fields, turbulence zones, where energy reorganizes before the next act. To you, they feel like the aurora inhaling. The effects are subtle but real. The same flows can tug on the ionosphere's density, bending radio paths and teasing GPS timing errors that ripple through navigation systems far below. A polar pilot relying on HF comms might hear black aurora as silence. You, standing in snow, feel only the hush before the sky hurls something stranger, a glow not quite aurora as you've known it. Level 6. Proton aurora. On the day side, near noon, and close to the magnetospheric cusp, the glow changes character smoother, foggier, often tinged with soft violet. This is proton aurora, born when energetic protons charge exchange with atmospheric atoms and become fast neutral hydrogen that lights faintly as it slows. To your eyes, proton aurora lacks the crisp curtains of electrons. It spreads like spill light diffuse, subdued, less eager to dance. Its spectrum shifts. Hydrogen emissions mix with oxygen and nitrogen, washing the greens into pastel hues. Cameras struggle, scientists do not. From orbit, proton aurora appears as a ghostly streak on the sunward side of Earth, proof that the day side is alive even when it looks calm. Protons strike deeper than electrons, sometimes depositing energy 100 kilometers below their counterparts. Each impact transfers momentum, subtly shaking the upper atmosphere. To an observer on the ground, it's a soft bruise of color on the horizon, barely visible through daylight's blue. Physically, it's fierce. Protons are heavy, and their footprints map how solar wind pressure punches Earth's magnetic shield. Where you stand, that pressure is invisible. Above, the magnetosphere bows inward like a drumskin. Human consequences follow the sunlight. On these dayside arcs, radio fades, GNSS signals wander, and polar flights may lose contact for minutes. You might never notice, but your world of signals does. And then, in the nightward sky, another phenomenon defies expectation. A mauve ribbon running straight across the heavens. Level 7. Steve, the sky's hot river. A narrow ribbon ignites far south of the usual auroral zone, straight, violet mauve, running for thousands of kilometers. Beneath it, a comb of green picket fence flickers. This is STEVE, strong thermal emission velocity enhancement, not a traditional aurora, but kin to it, an optical trace of a subauroral ion drift, where ions scream westward at several kilometers per second, and the upper atmosphere runs hot. You see Steve as a rule breaker. It appears during during geomagnetic activity, yet stands apart razor straight, sometimes arching, often lasting an hour. Its interior glows smooth and textureless. Unlike the curtain's wrinkled light, the color is uncanny, between lilac and amethyst, as if the sky itself had been heated beyond green. Amateur observers first caught it on camera, puzzled by the strange streak that didn't behave like any aurora they knew. They named it STEVE jokingly, and the name stuck even after physics decoded it. There's poetry in that, a friendly name for a fierce phenomenon, discovered not by observatories, but by patient eyes turned upward. In scientific terms, Steve marks a channel of intense electric fields, heating ions to thousands of degrees. The air thins, glows, and slides west at blistering speed. The picket fence below those flickering green pillars are separate, spawned by turbulent instabilities rippling along the boundary. Consequences ripple outward. Satellites passing through Steve's corridor encounter denser, hotter air and feel extra drag. Radio paths bend. Power grids already stressed by geomagnetic currents take another hit. Yet for you on a dark road, Steve is pure astonishment, an exclamation mark stitched across the firmament. And as storms deepen, a quieter, blood-red line appears, older, slower, ominously steady. Level 8, SAR arc, stable auroral red. A single red arc hangs across mid-latitudes, far from polar ovals, quiet, unwavering, blood warm. This is a stable auroral red arc, or SAR. It glows high above at 300 to 400 kilometers, where atomic oxygen radiates deep crimson light at 630 nanometers. Unlike the playful greens of electron aurora, SAR arcs are heat-made visible energy dumped into the ionosphere by ring current particles during geomagnetic storms. You stare and the red feels wrong, like a wound that never closes. There are no curtains, no motion, only a solemn band stretching across the sky. Because collisions are rare that high, atoms release their energy slowly. The color lingers, eerie and deliberate, the sky's slow burn. To scientists, SAR arcs are thermometers. They trace where the storm is cooking the upper atmosphere, where conductivity spreads heat along magnetic field lines like a hot wire through glass. To you, they make the familiar sky look foreign, as if Earth had slipped into another world. Consequences descend quietly. The heated air expands. Low Earth satellites plow through thicker drag. HF radio paths bend and fade. Power networks brace for geomagnetically induced currents. If you're far from the poles and see this crimson line, you're witnessing a system running hot. The magnetosphere has turned its warning lights on, and when the boundary between red and green starts to buckle, it forms luminous waves shaped like the last letter of a warning, the Greek omega. The next phase is motion on a planetary scale. Level 9, omega bands and auroral storm surge. Along the lower edge of the auroral oval, the bright boundary blooms into repeating Greek omega shapes, vast, scalloped waves rolling eastward. These are omega bands, colossal pulses of plasma, coupling space and atmosphere, transforming the quiet arc into a moving coastline of light. You can watch that shoreline form and dissolve. Bright heads, dim bays, a marching chain that swallows half the sky. The air seems to flow, though the wind at your face is still. Beneath these luminous waves, electric fields surge. The oval breathes outward, then snaps back like a tide whipped by a second moon. From above, auroral imagers on satellites see these structures crawl around the polar cap. Each omega crest marks a vortex, a rolling surge of energy where fast and slow plasma flows collide. To the magnetosphere, this is instability made visible, boundaries bending, then breaking. For scientists, omega bands are precursors, warnings that magnetic tension is about to release. For you, they are beauty in motion, slow as breath, yet immense as continents. The horizon shimmers, the sky folds itself into glowing waves, and your sense of scale fails. You are standing inside a slow explosion, the calm before a cosmic storm. Technological ripples follow, long pipelines hum with induced current. Power grids soak up stray electricity. Pilots see instruments flicker. To drivers who pull over to stare, it feels like the world has tilted, the heavens alive with liquid fire. Moments later, that warning becomes reality. The magnetosphere snaps, the night erupts. Level 10, Substorm Breakup, Coronal Aurora. At once, no countdown, the arc ruptures into a coronal blaze. Light fans out from a single point high overhead, like staring into the throat of a luminous tornado. Rayed curtains whip in every direction. Spirals curl and uncurl in seconds. This is Substorm Breakup, the magnetosphere's whip crack. When field lines reconnect and fling stored energy toward Earth, you feel it as a storm, with no sound, silent thunder, light with velocity. Curtains tear themselves apart, racing poleward at kilometers per per second. Colors surge, green and purple, blue and crimson, each layer from a different altitude, each hue a different collision energy. It's not just motion, it's acceleration. The sky itself caught in feedback. If you could see it from orbit, the auroral oval would bulge like a living organism, arcs twisting outward before snapping back. In the magnetotail, millions of cubic kilometers of plasma realign, hurling particles inward. The result is an electric hurricane wrapped around a planet. For you, it's an experience beyond speech. The stars vanish behind rippling plasma. Shadows dance on snow. Your breath catches as the heavens fracture into ribbons. Cameras can't keep up. It feels as if the planet's soul has opened and is staring back. For technology, this is stress incarnate. Currents race through power lines. Transformers heat. GPS drifts kilometers off. Radio dies across polar paths. Astronauts shelter. Earth, for a moment, becomes a resonant instrument of its own storm. And then, like all tempests, it fades, leaving a sky that glows, bruised and restless. But sometimes the storm does not stay confined to the poles. Sometimes it follows the magnetic field deep into latitudes where humanity sleeps unprepared. Level 11. Low-latitude aurora and superstorms. The aurora escapes the Arctic and Antarctic, spilling into lands that never expect it, deserts, tropics, coastlines lined with palms. During extreme geomagnetic storms, the auroral oval surges so far equatorward that city skylines glow. The color turns crimson, born from oxygen high above 300 kilometers, where air is thin and calm. You step outside somewhere far from the poles, and the sky is bleeding softly. A red dome swells from the horizon, sometimes striped with faint green. Pillars, arcs, and drapes rise over highways and rooftops where no one has language ready. Cameras show rivers of violet. News feeds fill with awe. The air feels electric, ancient, like the world itself is exhaling light. Historical records tell of such nights: 1859, 1921, 1989, when telegraph lines sparked and power grids fell. If a storm of that magnitude struck today, it would ripple through every system that defines civilization. Satellites would veer from orbit as the atmosphere puffed up. Power transformers could melt, GPS would wander, communication would falter, and yet above it all, the sky would remain heartbreakingly beautiful. In space, a coronal mass ejection, a mountain of plasma the size of planets, has rammed Earth's magnetic field. The shock compresses the magnetosphere, forcing currents into the ionosphere like veins bulging under pressure. The ring current deepens. Aurora flares across continents. For astronauts, radiation instruments scream. For you, standing in your driveway, it's light you'll never forget. These nights remind us that the sun is not distant. Its storms reach down, touching power lines and oceans, and for a few hours, the entire planet becomes luminous. When dawn finally arrives, the glow fades, leaving silence, wonder, and the faint metallic scent of charged air. The living shield. Aurora is not a single phenomenon. It is a symphony, 11 movements of light that let you watch Earth's magnetic heart in color. The soft wash of diffuse glow, the still geometry of a quiet arc, the curtains that ripple, the patches that pulse, the shadows that carve, the proton haze, the mauve river of Steve, the red endurance of SAR, the rolling omega waves, the explosive coronas, and the rare crimson domes above the tropics. Even when you cannot see them, the machinery continues, field lines stretching, snapping, currents racing through rock and ocean, plasma circling the planet in invisible belts. These lights are the visible pulse of an unseen shield, a reminder that Earth is not passive. It breathes, deflects, endures. You cannot touch it, yet it touches you in wonder, in data, in the fragile hum of every device that depends on the calm between storms. Most nights, it paints the poles and leaves the rest of us dreaming. But sometimes, it comes to the door and knocks. Look up when it does. Feel the planet breathing. Remember, this is what protection looks like. Beauty born from violence, color from collision. And if you want to keep traveling with us from polar lights to black holes, subscribe for more explorations.